Welcome everyone to this Swordfish School session. Swordfish School presentations are focused on a single swordfish topic. We introduce concept of supported features, generally just referred to as features, and how Swordfish correspondingly uses profiles, which are developed using the Redfish Interoperability Profile Specification. And given that that's a little bit of a tongue twister, I'll generally just refer to this as the profile language. I'm Richelle Ahlvers, a storage management software architect at Broadcom Inc. I'm responsible for the definition of storage management integration solutions and standard strategies for Broadcom's data center storage group. I've been involved here with SNIA for many years and am the chair of the Scalable Storage Management Technical Work Group, or the SSM TWIG, which has developed the SNIA Swordfish specification. I'm also on the SNIA Board of Directors. If you have any questions you'd like to ask during the presentation, just type them into the BrightTalk Ask a Question box. My lovely assistant Linda is with me on the line today and will collect the questions. We will answer them during a Q&A session following the presentation portion. We expect to have at least 10 or 15 minutes for the Q&A session. Let's see, some other housekeeping items. In the attachments and links section, you can find pointers to materials that include everything I will be covering today. This presentation will also be available on our SNIA video YouTube channel as part of our ongoing Swordfish School series. I will be going back and forth today between slides and screen share mode, so I would encourage you to view this full screen. You can do this by clicking on the expand icon near the lower right-hand corner of the display. If there are any issues with the display, please submit via the Q&A mechanism. There is at least a 90-second delay in this format between my presentation and when you can view it. So please submit your questions during the presentation as we go, keeping this in mind for the Q&A session as well. Okay, with all of that housekeeping items done, let's go ahead and get started. Oh, I think there's actually a little bit more. Just a couple of disclaimer items before we get started as well. The contents I'm going to be going over have been released at so there are some materials that we know that will be updated and enhanced before we release as a final version or we release as a formal specification. Part of putting this presentation out today and as well as putting this tutorial together is we really would love to get feedback both on the concepts and the materials as they are out as the work in progress 0.9 and as we release materials. So please provide feedback either today or as we go. There's a feedback portal on the SNIA.org website or contact us directly to provide feedback. So, jumping right in, what are features or supported features? I will generally just refer to these as features. That's a little bit confusing. What you'll see in the schema, what you'll see in the registries, they're officially referred to as supported features. But what these are high-level descriptions of functionality, grouped functionality that an implementation can advertise that it can support. And so the mechanism that it will use to advertise them is a supported features registry. If you're familiar with Swordfish and Redfish infrastructure, there are multiple types of registries that exist today. So we've created a new registry type called the supported features registry. So there's a message registry, there's a privilege registry, there's several other registries. This is just a new type of registry where a client can go to an implementation and say, what features do you support? And it can advertise through that mechanism. I'm going to go through kind of the overview first, and then we'll kind of go, I'll show you kind of the detailed examples of the schema and of the detailed registries that are included in the bundle, so you can see those and walk through and understand the layouts of those. So we'll go through these overviews first. Correspondingly then, what are profiles and how is Swordfish using them? So profiles is a term that is used in a lot of different ways, a lot of different contexts, consistently to previous storage management standards from SNIA. These are detailed descriptions that describe down to the individual property level what functionality is required. This corresponds directly in order to advertise features. So different profile definitions can exist for same feature types. An example of this would be discovery or provisioning. You would have different requirements for provisioning for a block implementation than you would for a file implementation, and I will show you the specific examples of that later. Now, remember that an implementation will advertise features. Profiles, because they are used primarily in development, tools for developers, and for test. They're not just used on the service side. The client implementations can use them as well, but again, they're not used at runtime. And this really just highlights a lot of what I've been saying, so I'll repeat kind of the characterization here of when and where you use these. At runtime, the clients can look for those advertised supported features. You look for those from the registry. And at development, you use those profiles for the very specific functionality to see what corresponds to, from the service side, the provider side, you say, can I advertise that feature? What specifically functionality do I need to implement to say, can I advertise that feature? From a client perspective, does this specific instance of a system support the feature I'm looking for? And then on the profile side, here's all the details when I'm building the system, when I'm testing the system. So one of the things we've talked about a lot from what a developer would do, but how do you qualify that? There are a lot of different, that's a very important feature of the overall ecosystem as well. One of the things we'll be looking at is a Swordfish CTP conformance program, similarly to previous incarnations of management programs that you will use profiles for. We also have other test programs we'd expect that for. So additional profiles for Energy Star that's orthogonal to this sort of profiles. We're also partnering with other organizations like OCP is developing profiles. They've got redfish profiles. We would expect also to see groups like ODCC have a corollary. And we're also partnering with groups like OpenSDS who are leveraging Swordfish but would have higher order profiles than the ones we'll be talking about today. And those groups would be looking at different sets of profiles, but using the base profiles and the same mechanisms to do conformance or potentially even certification of functionality. Okay, so jumping in a little bit, what do these look like? So the bundle that's in the link today and that we've released as a WIP, we're calling the Swordfish Core Profile. And what we've developed here is really a set of supported features and a set of profiles that help define what base and standard a standard set of functionality for Swordfish implementations to look at implementing. And how we did this was we characterized from a set of primary client requirements. We worked with a set of clients to say what are groups of functionality and groups of use cases that you would specifically look for from implementations, and we put those together. So we have kind of this set of standard and advanced, and it's what would you, and this is how these have been organized and put together. So we start, and these build on each other, and I'll show you that hierarchy in a little bit as well. But we start with a set of standard features, and you can see these are pretty coarse-grained. I support discovery. Now, we say discovery in inventory because discovery could be, yes, I exist. Inventory is, I exist and I can see all my properties. So we put those together because that's kind of an obvious grouping, even though those are really two separate, scenarios from a client perspective. And then building on top of that, event notification, performance instrumentation, basic provisioning. I can create volumes. I can create file systems. You can see how those logically fall out. And then we move into advanced features. I support replication, but you have to break those things down from local replication versus remote replication. And then we get to a couple of other permutations that had that the clients cared about, but which were I want to be able to do advanced configuration, advanced capacity management, advanced configuration management, which is really, as you dig into this, some of these things in version 1 are really fairly simple, but this is really what we kept these fairly simple because at least for this initial implementation and initial bundling, this is really very client-driven. This is where they asked us to focus initially. Corresponds to, can you expand your volumes? Can you expand your file systems? And then mapping and masking for grouping and access control. There's a lot of additional capabilities in the systems, but we really focused here on not necessarily what all the functionalities devices could support, but what the clients asked us for. Okay, so let's talk a little bit more about how those are structured and what we mean by that. So this talks a little bit about, what each of those means. Some of these are really fairly obvious, and what you'll see is a lot of these are fairly simple. And these may get more complicated over time, but we kind of felt that, starting with developing the ecosystem here and starting with relatively simple, straightforward mappings and implementations, rather than waiting until we had really complex solutions was the right approach. So we've already talked a little bit about discovery and inventory here. You can see we talk about, I'll go through here. This is the block, and then I'll show the corresponding version of file, and then I will show you, I'll toggle over and actually show you how these things get mapped into the profile language. So for discovery and inventory, as an example, we have, what does that actually mean? So we've got, when you map that to an implementation, you've basically got a set of required properties or a set of required functions that need to be there. And when they are there, you must be able to read them. Sounds straightforward, right? That's pretty much all that we need to specify. You need to be able to do a read on any object and read on any properties that are implemented. Once you say it, it sounds really obvious, but that's really all that falls into this category. So event notification. Now, this one's actually a little bit more complicated, so we expect to see this one stage in. One of the things we've done up front is we've actually built in a set of a resource event model And so this is built into both the Swordfish specification and now into the profiles. We've been very clear that Swordfish implementations shall use the resource event registry model that we have developed, and there's some other supplemental things, but at a bare minimum, they shall use the resource event model. So the profile initially starts with the resource event registry, and so that is clearly specified in this profile. Performance reporting is if you want to claim this anytime you have in a block model, if you have a volume, you support the performance reporting. If you support a storage pool, you support this. Similarly, in the file system, there's the corresponding requirements. Basic, provisioning. This one is, again, and I'll show this as an example in a minute. This one sounds like it should be fairly straightforward. It really is. You need to be able to create volumes. So these look fairly straightforward and look like if you were thinking about how to build a hierarchy, what's required for event notification, it builds on discovery. Performance requires discovery. Provisioning requires discovery. When you start to get into more of these advanced ones, the hierarchy is still, we've kept it very simple. Replication requires provisioning. Mapping and masking requires provisioning. Capacity management requires provisioning. So we've tried to keep everything structured so that there's just one dependency within the profiles themselves. Okay, so when we go over to file, some of these have been common, but we have a subset of these that have file-specific versions. So discovery is common. We've kept a lot of that common. Event notification, a lot of that is common. The performance reporting, a lot of it is it's common requirements, but it's different classes, which I think that's quite true for the discovery as well. Provisioning, same thing. Common requirements, but applied to different classes. So instead of requiring the ability to create volumes or create and delete volumes, you're actually creating and deleting file systems, and then if they're implemented, creating file shares. So that gives kind of an overview of, for each function, there's a corresponding set of functionality. It's not super comprehensive functionality. I guess I didn't go through the replication ones, which have a little bit more complexity to them. But let me just toggle over now to show what those profiles actually look like and how those things are structured. So if we look at the discovery example, this is what the profile itself looks like. So in that simple mapping, we said, well, we want swordfish discovery. It basically needs to show, what are the few required elements, and that you need to be able to do gets on them. So this is the way the profile language, that Redfish interoperability profile specification, or profile language has this thing structured. So we have these things. I believe they're relatively easy to read because we have them broken up. We wish there was a way to put more, we'll call them comments in here, but there's not really a comment capability in. The only thing is occasionally you can use this purpose statement. We've provided the feedback that we'd like the ability to put some comments in just to make it a little bit clearer to read. But what we basically do is we start with at the root. At the root, we basically say For the existing spec versions, Swordfish requires storage services. So what we say is you must have the storage service collection. A collection is a group. It's basically the way this language does an array of things. So a collection is an array. It says you must have, the array must exist, right? This basically says for that type of array, you must have at least one of them. So we're basically saying for a Swordfish implementation, you must have at least one storage service. And that corresponds to exactly what we say in the Swordfish specification. Let's see. We also say you must have, aside, in addition to what's in the retrospec, there's a set of required properties. In addition to those set of required properties, you must have these properties, and they must be read-only. We're not saying anything else there. This particular notation, we could have said, read requirement in here, but the shortened notation here is basically means read requirement. So you must have the identifier property. You must have a status property with state and health subproperties. You must have a class of service collection. Again, this is the classes of service collection. When you're first instantiated, you don't actually have to have a class of service because it may get instantiated after your system at initial. It may not be there at initial initial bring up. It may be built later. So that's why that's a 0. So going on down here a little further, you have to have the link to what kind of to this other object in here that says, what kind of system the storage service is hosted on. We have 2 different variants of systems right now. We have what we call a hosted service configuration and integrated service configuration. Integrated service configuration is largely like a direct attach style model. So it would be hosted or it'd be attached to a RAID card or something like that, and that's modeled as a storage class. So this is basically helps to specify how your controllers are modeled. And then this basically says when you do get those classes of service, set your default class of service. And then, there's just a couple of other things here that basically says you need to have at least some form of line of service capability. You have to have at least one kind of capability specified so that you can go create your lines of lines of service and classes of service. And then this conditional requirement basically says you got to have some form of media in there. If it's drives, put them here. If you're using some other form of media, like persistent memory, something else, put it someplace else. But we're pre-enabling, it'll largely be drives initially, but we're pre-enabling persistent memory and other things in the language we use here. So you can see this discovery is not, even at this base level, you would expect discovery to be really extensive, and it's actually not. I know I've spent a fair amount of time walking through this one. I'm going to jump to another one because I've said some of these are really small, and I kind of wanted to highlight that. So if we go to block provisioning, this one is 45 lines long, and you can see a whole lot of these are just and brackets. So similarly, one of the things we'll show up at the top here, and I didn't highlight on the last one, is there's required profiles. Just basically talks about the point that I highlighted earlier. This builds on and requires the Swordfish discovery that we just looked at. Incorporates all of those, says all those pre-requirements are required for this. This registry item, I should have highlighted on the last one, but that's okay, I'll get it now. This is how we correspond the feature to this requirement. So this one basically says this block provisioning corresponds to this feature that's in the feature registry. And I will show you the feature registry mechanisms in a little bit. So in here, we had that really simple definition for block provisioning. So it was, if you recall correctly, it basically just said, I need to be able to create and delete volumes. So there's two specifications in here, two things we call out. One is, again, within that storage service, you need to have that volumes collection. And then on any volume, well, on these three specific volume collections we call out, both the storage service one and then ones within storage pool and capacity source, they need to be modifiable, right? That create and delete that we said. So that's really all that's specified here. So this, when we talked about these things being testable and being input into a test case, you can see how this basically could say, for any of these types of, if these exist in an implementation, you can test this using this, I can test for the existence of this, and then I can test if your implementation supports that by looking at these statements. So that's both, how an implementer can check and say, do I do these things, but also how do I test against them? There's variants of all these things. You can see the mappings between them. And then the other one that's a little bit different that I also talked through is the event notification. The event notification, because it's pulling in requirements from multiple registries, actually works a little bit differently. So you can see up here we pulled in the features registry that says, again, that SNIA Swordfish event notification. And then we go over here and we start pulling in from the other registries. Right now it basically says, I'm going to pull, you're going to use this registry entry from this, it pulls in from the Redfish base registry. And it tells you specifically when to use this event. This one is a little bit harder to build tests around because it's not really built into the profile language. So we're, again, working with the Redfish folks on specifically how to do that. But this one we basically have written into the purpose and explicitly given the developers when do you use this language. So we can, for example, building a conformance test, you can actually build tests to say, I see somebody did this case, I expect to see this kind of event generated. So this basically builds in the explicit language of when you should or shall, basically shall, when an implementation needs to generate one of these in order to claim conformance to this. And be able to advertise the event notification feature. And we haven't made this extremely comprehensive. We basically said, again, I noted this earlier, for this particular event registry, this is how you should use all of these. And we expect to expand this one over time. But we basically put this entire one in that we helped develop, again, with the help of input from some of our clients. Okay, so I guess the only other thing I'll show is that I did mention, that these things build on each other. So this one, instead of the block that builds on discovery, but then we have like remote replication that actually builds on provisioning. So it's a single stream all the way up. All right, going back over here. So the next thing I'll transition over and talk more about how the supported features are implemented. The features, supported features are implemented, are designed and implemented very consistently with the other registries. So if you're familiar at all with the message registries, this is going to look very, very similar. But what we did here was we basically set when you advertise a supported feature, it's got 4 things in there. It's we start a feature name, a description of version, and then the corresponding profile definitions, the things we've been looking at. And so the features registry is accessible at the service root. It's not going to be, it's just basically there right with the other registries. And will work consistently with the other registries as well. So you can register, clients can go basically access the supported features registry independent of any individual object in the system. Okay, so when we look at, I will actually show, let me just toggle back over to the screen share. That one was put in just as an example, but we can actually look at the code itself. So the features registry, again, is structured, this is the registry itself. So it's got a bunch of header information for interacting with it, and then it's got that supported features structure. More interestingly, when you're interacting with it though, is the Swordfish feature registry, which contains the standard messages or the standard features that you would publish to a client. So if you support discovery, event notification, and block provisioning, you would basically take these, I said 4 fields, right? Here's the 4 fields: the name, description, version, and corresponding profile definition. Now there's another another schema type in Redfish that will actually be used with this name to basically flush it all out. That we're stealing completely from the message registries, which is the registry file definition. So that mechanism will be used in an implementation to say, to point to, this is where you can find this registry online. This is where I have an archived copy in my implementation. So we don't need to provide any of that information there. We just basically say, here's the base file name. And then the implementation can leverage that file list construct that from message registry into the supported feature registry construct. So the fact that these will live at dmtf.org/registries/swordfish will all be can all be embedded in the implementation. And then if someone is building a embedded implementation, they can actually also embed the version, the Swordfish registry, and then if they have a features registry, and then if they have an OEM version as well, and embed that as well. That can all be information that's embedded and presented to the client, so they can get the archive version if you don't believe your clients will be able to get to the public version. So there's those options, but we don't have to embed that in here. We just use that standard Redfish mechanism. But you can see all of the ones we've talked about: Swordfish discovery, Swordfish event notification, block IO performance, provisioning, local and remote replication, mapping and masking, capacity management, and then file provisioning and file capacity management. Okay, let's see, I think that was everything I wanted to cover. So I will stop there and see if we can switch over and see what questions we have from the audience at this point. All right, first question. You mentioned using this in the Swordfish CTP program. How would that work? Okay, great question. Thank you. So we are in the process of developing the Swordfish Conformance Test Program. And similarly to the existing SNIA CTP program, we expect to base that in part on the profiles. And what we're actually planning to do is take the take a bunch of existing infrastructure that exists, the interoperability profile validator that Redfish has developed, and some of these tools are available in open source, and take a test framework, and then you basically take an implementation, take these profiles and a bunch of other tools, because as I mentioned with the event ones, you'll have to feed those in around you know, because these profiles are fairly small, but feed those in around and say, okay, here's a test, you know, do you support this? But also, when I run this, do I get back what I expected to get back? And we're leveraging a lot of infrastructure that the Redfish program has already developed, so we expect to ramp that program up relatively quickly. So the profiles, the same way we build on them here, we will, you know, we'll be looking at implementations to say advertising a supported feature. We can use that to see, you know, to basically automate the tests and say, you're advertising discovery, I'm going to run the discovery test. Although we can also, you know, just run through the entire suite of tests. But so there's a lot of stuff we can actually do there based on using both the supported features and the profiles. But we expect to use the profiles as, you know, one leg of the test suite, which is very similar to what the SNIA folks did. They just happen to have like 180 variants of profiles. We're starting with, you know, a much more simplified view of the profiles. Okay, next question. Can you recap what other types of profiles we can expect to see? Well, yeah. So this is actually there's two new sets of profiles that we expect to see coming out very soon. One of them just got approved for release yesterday, so it should be up on the website hopefully by the end of this week, beginning of next week. But one of the things we have developed, and this is a completely orthogonal profile to the this set of profiles. We've been working with the SNIA Green Twig, who have been working with the EPA and the SNIA Emerald program to develop Energy Star requirements for storage. And so what we have done is we have taken those Energy Star requirements and mapped them to swordfish properties and developed a profile that products can use to work with. This is really more for a working with the EPA to qualify products rather than a runtime set of requirements, but they can basically advertise the Energy Star capability, and then the EPA can develop a test or interface, really, as opposed to a test, an interface that they can use to test programs that advertise the Energy Star capability. To do automated and hopefully, you know, shorten their cycle for doing, you know, Energy Star certification via Swordfish APIs. So we're very excited about that one. We think that one's part of it is that it's actually a really simple. It's a really simple profile, and it should actually also make a really straightforward use case for folks. It's something that we've been wanting to do for a long time, but we haven't had a clear way to develop a good Energy Star programmatic API. Okay, next one. There was a question: is Swordfish just a spec, or is it a functioning product at this time? Well, the SNIA develops the specifications for vendors to implement. There are both implemented versions of the spec at this point from multiple vendors. There are also a couple of companies that have put out some reference implementations. In addition, if you go to the first link on here, SNIA.org/swordfish, you will find links to everything that I've talked about. We also have a few reference implementations and samples, sample tools and things referenced. There's a link to our GitHub site, which is github.org/SNIA, covers Swordfish and as well as our cloud APIs as well for CDMI. But there are multiple multiple reference samples and other tools there to help accelerate development. Let's see, can you use the profiles without advertising features? Yes, you can. However, we implemented the supported features capability for at our client's request, because really the clients are the ones that wanted us to come in and be able to understand very clearly and succinctly what a given implementation could support, and what a specific instantiation of an implementation, to be very clear, was capable of supporting. You may have 2 or 3 different products sitting side by side from the same vendor of the same version, but one may be able to support, for example, local replication, and the next one can't, simply because it doesn't have, it doesn't have it's not licensed for it, or remote replication is a better case here. Remote replication, it may not actually be configured in a way that is capable of supporting remote replication. So that's functionality that we've had very clear requests from the clients. So profiles can absolutely be used, particularly in conformance testing. We can go run conformance tests against products that aren't advertising features and say, yes, you're conforming, and you can get your conformance, you can pass the conformance for various levels and things. But the features and the supported features we really added based on our client's request. One of the other cases I heard where supported features might also be really useful, I just heard yesterday, when one of an OEM asked, what if I have to do permutations where I have 2 profiles or multiple profiles that may have conflicting requirements, not necessarily the Swordfish ones here, but one vendor wants me to put manufacturing data in one way, and another one wants me to put manufacturing data, fill in vendor ID one way, and the other one wants me to fill it in another way. You could potentially build OEM variants of features and fill in and advertise, I am OEM, feature X, and this one is OEM feature Y. And then it's clear from the client to be able to differentiate, one versus another. Let's see. Okay, there's another question in here. What vendors and products are using Swordfish and Redfish? That's a big question. There are a tremendous number of companies that are involved in the development and support of both Redfish and Swordfish, and it is expanding broadly daily. I mentioned that we have multiple implementations right now of Swordfish, and in particular, we have at least half a dozen implementations right now. Obviously, nothing, because we haven't developed the CTP program. Nobody's gone through that yet. And on the Redfish side, there's a lot of them. One of the things we're doing right now is developing a program or developing functionality, which I meant to mention when we're talking about what are the other profiles that are coming up. This set of profiles and functionality is and you'll see the language in it. It says for service-based. It all depends on and requirements based on having Swordfish with class of service functionality. We've had requests to expand the capabilities of Swordfish to a more traditional management model. And so we will be rolling that out in the next couple of months. And so we expect to see some of the existing redfish vendors expand very quickly to including Swordfish functionality using that non-service-based model, which we're still working on exact branding there. I'm just calling it non-service-based to differentiate from those that have class of service. Between redfish and swordfish, there are a large number of vendors using across a broad range of environments that have adopted. You have pretty much all of your traditional server vendors. We have folks deploying software-defined storage. We have folks in the NVMe over Fabric space. I don't have a solid count for you, but we know we have 60 vendors probably between the two organizations that are involved in developing and supporting the development of redfish and swordfish. Let's see. So do we have any other questions that have come in, or let's see, let me just recap a little bit here. There are a few other online resources. I will recap again. For additional topics in the Swordfish School, which to differentiate our couple of types of our training materials, Swordfish School is focused on specific individual topics for swordfish. There's a corresponding topic stream in redfish called Redfish School, available on the DMTF YouTube channel, and Swordfish School are on the SNIA Video YouTube channel. Any other materials for swordfish, and also to find links to anything, please go to snia.org/swordfish. If you are working on implementations or just have general questions, there is the redfishforum.com or swordfishforum.com. If you are a member of SNIA, would like to join SNIA, would like to participate in the development of the specification, please go to snia.org. There is a feedback portal available there as well. And we would love to have anyone and everyone involved in the development of Swordfish. If you are a member of another forum, I would just like to provide feedback on the profiles. You can do that directly through the SNIA feedback mechanism, which is available. The links to that are available in the profiles bundle, or you can also do that on the Swordfish forum at swordfishforum.com. Let's see, one more. Okay, I think, okay, so then the question is, there's a multi-part question in here, so I'm going to try and I'm going to pick out a couple of different parts in here. Who is running Swordfish in production? I have no idea. We have a couple of vendors that have released implementations, but we don't have any information on their customers and where they are in adoption cycles. We'd have to refer to their marketing teams to answer any questions there. I would say they're probably mostly actual customers. The next part of the question was university or company. I would say they're probably mostly company rather than university. Although we do have some, we have some university projects that we're working with a NSF-funded project out of the one of the groups that works with that is out of the Texas Tech University. They have actually built one of our development open source tools that builds on our emulator, and you can stand up and build a scale-out swordfish-based scale-out swordfish data center as a development and test tool, and that's available. There's a link from our Swordfish page. You can basically build that up in a Docker environment in minutes, which is really awesome. So let's see, next question is, Swordfish have, well, it says NAS protocols. This is all around management. So we do have file system and file share management that can configure NAS SMB. So all of that is actually built in. And so we have the capability to manage any of the NAS products. We have multiple NAS vendors who participate in the twig and are looking at Swordfish for NAS management capabilities in the future. We do not have anyone that's announced product in that space, but we do have some that are looking at potentially POCs. Since they haven't announced it, I cannot comment as to which companies those would be. Oh, just as a note, I keep probably talking past it. One of the companies that has released a shipping version of Swordfish is actually a startup called X10, E-X-T-E-N. They won Best of Show with that as a startup last year at Flash Memory Summit, because of their product, and as also in conjunction with their Swordfish implementation last year. That would be an interesting. We're looking at potentially having our marketing team look at doing a where are they now use case kind of solution there. A lot of our others implementations would be. I mentioned would be just more of your classic existing products, but I'll mention that one because it was kind of going into a new market segment with the NVMe over Fabrics and Flash segment, and I had glossed over that kind of briefly. We find it very interesting to see not just traditional storage vendors and server vendors, but also to see software-defined storage and NVMe over Fabrics also expressing interest and reaching out and working with Swordfish on bringing Swordfish in as their standard management API. All right, we'd like to thank everyone for attending today. And we hope you have a little better understanding of what Swordfish supported features and profiles are, what they're used for, and how we expect folks to use them when developing implementations or test suites. Remember, you can find more information about Swordfish at snia.org/swordfish, or if you're looking for information about redfish at dmtf.org/redfish. Please take the time to rate this session. We hope you found it interesting and useful, and we thank you in advance for your positive reviews and comments. Remember to watch for more sessions about Swordfish in the near future, both here and on our YouTube channel.